In this video, we're going to look at how to find different p-values using a t-table. And so remember that anytime that you're working with means and hypothesis tests, you're going to be using that t-table to find a range of values for the p-value. All right, so in this first one, we have the hypotheses. Under the null, mu is equal to 7, and under the alternative, it's less than 7. So looking here, we've got the less than sign in the alternative. You can think of that as kind of an arrow that's pointing to the left. So this is a left-tailed test. And if we drew a picture of what the distribution would look like, we'd have our t-distribution, which is centered at 0. And our test statistic is negative 2.0371. And we are interested in the area to the left of that test statistic. And so this area is equal to the p-value. So we need to figure out what that area is. Further, notice that we have n equal to 34, so we know the degrees of freedom for this t-distribution are equal to 34 minus 1, which is equal to 33. So we're going to use our t-table to help us figure out a range of values for this area. So if we go over to our t-table, so here's our t-table. So let me erase this. This is from another video I was making. So we had that our degrees of freedom were equal to 33. And just to glance back here, we also had that our test statistic, our t-statistic was negative 2.0371. So our test statistic was equal to negative 2.0371. All right, so we do not have a line with degrees of freedom 33. So going down, the closest one we have is 30. So we're going to look at the 30 line. And notice that all of these values are positive. So even if you get a negative test statistic, which you'll usually have for a left tail test, we're only going to look at the positive value. And what we're going to do is we're going to find what two numbers 2.0371 falls between. So looking through here, we see that it falls between these two numbers right here. So now going up to the top, notice that it says one tail or two tail. Well, since we're in the left tail, this is a one-tailed test. We're not in both of them. So again, moving up, we know that our p-value is somewhere between 0.05 and 0.025. So when we write it down, we want to write the smaller value first. We know the p-value is somewhere bigger than the smaller one and somewhere less than the bigger of the two. And so going back on our paper, we would write that. We would say that the p-value is somewhere between 0.025 and 0.05. All right, looking at the next one. Again, we have our hypotheses, but notice this time we have a not equal to sign in the alternative. So this means we have a two-tailed test. And now we've got n is equal to 56, and our test statistic is 3.0371. So again, drawing our t-distribution, which is always centered at 0, my test statistic is 3.0371. So that means I'm interested in the area above it, but then applying symmetry, since it's a two-tailed test, I'm also interested in the area below the negative value. So again, this area that's shaded in is equal to the p-value. So I'm going to use the t-table to help me. So again, n is equal to 56, so I need a t-distribution with degrees of freedom equal to 56 minus 1, which is 55. So let's go back to our t-table. So I'm going to erase the previous work we had. All right, so this time, just going back here, we have got 55 degrees of freedom And our test statistic was equal to 3.0371. Alright, so we do not have a 55 line, so moving down, the next closest is the 40. And we want to find the two values that 3.0371 are between. It's going to be these two. So moving up, notice that this row gives the two-tailed. So our p-value is going to be between these two numbers. So we've got 0.002. The p-value is going to be less than that, or probably bigger than that number, but less than 0.01. And again, the reason that I'm flipping the numbers from what they are up here is the table has them descending, but we want to have them read from left to right when we write them out. So we know the p-value is bigger than the smaller one, but somewhere less than the bigger of the two. So writing that down. .01. So again, now we have a range for the p-value. Now our last example here is we've got our hypotheses, but now notice we're going to try to prove that mu is greater than 7. We've got n is equal to 34, and our test statistic is now equal to this. So again, I'm going to draw my t-distribution. It's centered at 0. Now my test statistic is 1.0245. So my p-value is the area under the curve greater than that. My degrees of freedom are going to be equal to 34 minus 1. So going over to my t-table. Erasing what we had. Alright, so my degrees of freedom are now 34. And my test statistic, oh, sorry, that should have said degrees of freedom 33, 1.0245. And again, that's 33 here, not 34. Well, again, we don't have a 33 on the table, but moving down, the next closest is 30. And if we look at 1.0245, going to be between these two numbers. And again, since we're in the right tail now, we're only in a single one of the tails. So we're going to look at the one-tailed option here. So looking up, we know the p-value is between these two numbers. So the p-value is somewhere bigger than 0.15 and somewhere less than 0.20. So going back. So those are the three different types of tests you'll work with: the left tail, the right tail, and the two-tailed. And again, these are all for finding hypothesis tests involving means where you're using a t-table.